Boa tarde a todos, obrigado pela vossa presença. Vamos então ter aqui o nosso primeiro orador da tarde na sala Code 2, a Joana Maria, Scientific Manager da Vortex. A Joana é responsável pela estratégia e pelo portfólio na parte de gestão científica, tem um PhD pela Universidade do Illinois, nos Estados Unidos, tem estado mais do outro lado do Atlântico, não é verdade? E fez também, como curiosidade, um projeto de voluntariado em 2018, onde trabalhou numa organização que ajudava as empresas remotas num projeto de energia solar, a de facto providenciar energia a essas pessoas, e vai-nos falar um bocadinho sobre as contribuições dos serviços cognitivos, em parceria também com a Altran, na indústria automotiva. Obrigado. Obrigado, Joana. A sessão vai ser feita em inglês também. Espero que não haja problema. De qualquer forma, vamos ter depois as sessões transcritas no site do Building the Future. Podem ter acesso à transcrição também. Obrigado.
Okay, obrigado.
Obrigado, Joana.
Hi everyone, thank you for being here. So I'm excited to talk to you about how the auto industry is harnessing the power of cognitive. I'm sorry, I guess I should put this first. So I'm going to talk to you about how the auto industry is harnessing the power of cognitive services as a business differentiator that can help their bottom line. And so I'm going to begin with a brief intro into what cognitive computing is, and then I'll cover how cognitive services are transforming the auto industry, and then I'll share some use cases that we've been working on both at Altran and at Vortex. And so I'll just give a brief intro into what, I guess everybody knows Altran, but what about Altran and Vortex, and then I'll move on to the topic of the talk. So Altran is a global innovation and engineering consulting firm that operates primarily in high technology, and it has a big, strong footprint in automotive, and so that's why we kind of chose this topic for the talk. So last year, Altran, together with 4 other associates, and this is 3 academic research centers and 1 other company, they launched this effort to create a collaborative laboratory with the goal to boost their R&D and innovation capacity. So Vortex is 1 out of 26 collaborative labs in Portugal. This is an initiative from the Portuguese government to build this kind of labs. And our mission is to bridge the innovation gap that exists between academia and the business, and to accelerate the launch to market of cutting-edge cyber-physical systems and cybersecurity solutions. At the same time, the other goal is to stimulate the creation of skilled and scientific jobs. And so basically we sit in the middle of these 2 types of organizations, and we receive the discoveries and technologies developed at the academic centers. We accelerate them into proofs of concept or minimum viable products, and then we transfer them to our industrial partners. So many people are claiming that we have now entered the 3rd era of computing. So basically we went from the mechanical systems that could do simple tasks like calculations in the 1900s to programmable systems in the 1950s. And this transition allowed for huge improvements in performance capability. But in the last decade, we had this access to massive amounts of data. And also there was a big push and advance in AI technologies, and so this led to a new era of computation that is called the cognitive era. And so what is different about this era? So unlike the previous eras where we had to program computers, the cognitive systems, they learn from the data and they reason from models, and they also can interact with us, or we can interact with them. And they can perform tasks better than either human or machine would perform, because we are good at different things. So basically, these cognitive systems, they help us perform like the best person in each domain area, like an expert in each domain area. And so sometimes they play the role of a coach to us, but other times they can also act autonomously in many problem-solving situations. And so why now are we entering this cognitive era? So basically, there was a combination and convergence of technologies that led to the rise of this type of services. One is the almost limitless computing capacity of the cloud. The other is the vast amounts of structured and unstructured data. So that's a big difference for cognitive, is that the algorithms can also understand unstructured data, like pictures or the PDF or other things like that. And there are also lots of developments in terms of algorithms and training methods, and basically a lot of the advances we see these days is due to advances in deep learning. And commercially, you can find a lot of SDKs and APIs, and it makes connecting these type of technologies to the cloud pretty easy, and that allows the AI democratization. So basically, developers, they can easily go to a platform like Azure and use Microsoft's cognitive services to develop a facial recognition or a voice recognition system, just with a few lines of code. So they don't need to be an AI expert, and they don't need to develop the algorithms themselves. So I wanted to talk about what makes a system a cognitive system. So one of the features is that they have to be adaptive. So that means they can learn from its surroundings like a human instead of being programmed. And they also need to learn as the goals and objectives change. And so you cannot do that when you are programming a computer. Another aspect of cognitive computing is they have to be interactive. So this human-computer interaction is a critical part. So we need to be able to interact with the systems and define our needs so that we can improve our productivity. Another feature is that they should be iterative and stateful. So basically, they should remember previous interactions and return information that is useful to you at this moment and to the specific question you're asking. And also, if you're stating a problem that is vague, it should be able, because of that past information, to figure out what is the solution you're looking for or the information you're looking for. The last thing is it should be contextual. So it should understand and identify contextual data. So it should understand things like what is the meaning of things we're saying, understand that we're talking about a location, be able to understand what a user profile is telling us. And so a lot of the applications we see today, like e-commerce and like chatbots, they already have a lot of these features. They don't have all of them, but we're going in that direction. Another thing I wanted to talk about is there are three main broad areas of capability for these systems. And the first one is engagement. And this is in this one, it's the capability to provide the humans with expert knowledge or assistance. So for example, a chatbot is an example of engagement. Decision systems, they're a little bit ahead in terms of cognitive capabilities. And in this case, they have decision-making capabilities. So they're able to interpret the information and give you advice. So today, we are not quite at the autonomous, they make the decisions themselves, but we're at the stage where we have the recommender systems like Netflix or Amazon that they provide you options and then they let you choose what you want to do. So you're the ultimate decider. The other one is discovery, and this one is where we want to get. So this one it discovers insights in a huge amount of data, so that's something they are good at and we humans are not good at, but they also understand what they're looking for. So for example, you start to see systems like these that they ingest a lot of information from, like for example, medicine, and they read all these papers, and then they can make a recommendation for, oh, you should look at this gene to try to find the therapeutics, because from all of our reading, we identify this gene. So that saves months of time that if compared to having individual researchers go to read all those papers and reach that conclusion. And now I'm going to go into the cognitive, how cognitive computing is disrupting the businesses. And so auto industry is suffering more changes or it's going to suffer more changes in the next decade than it suffered altogether in the previous decades. And basically, it's a combination of factors. The consumer taste and expectations are changing, so we're all used to our iPhones and to have quick answers. So they're expecting the car to provide some of these features. There's also this modern technology that can be used in auto industry, and there's also like higher safety standards. And so right now the auto companies are, So right now, the auto companies are at this inflection point of that they know the technology is market ready and that they recognize that the industry itself is going to adopt these solutions, and they're preparing their organizations to also adopt cognitive services for their business transformation. And so this amount of data just keeps increasing by the day, so the cars just keep getting more sensors. And this gives the auto company also, not just the car has more data, but the way they interact with customers through the websites or through apps. The auto companies, they're getting more and more data. And this gives them the opportunity to provide great vehicle experiences and to personalize their marketing campaigns. But a lot of this data is unstructured, like I mentioned before. So the traditional analytics, that doesn't work anymore. So to really cover the full spectrum of the data and recover insights from that, you need to use new methodologies and cognitive capabilities, such like computer vision, speech recognition, pattern identification, and even elements from robotics. And again, some of these you already find in these platforms, and you can just use the API and apply them to your projects. And so what we're seeing is that today's vehicles, they are just not a mere transportation system that takes us from point A to B. They're also kind of a moving center on wheels. And so these cognitive services, you can harness this real-time data the car is acquiring and to provide a safer experience and to provide these vehicle experiences. And so I'm going to briefly look into these three different areas and how cognitive computing is impacting these areas. So for example, you can think about using biometric authentication. So you can use for the car, for identifying the driver and unlock and start the engine. So you can use a fingerprint, or you can use face recognition, and it would automatically just start the car for you. Another thing is it can identify the driver. So imagine you share the car with someone, so it can identify you as the driver, and then it will adjust the car automatically to all your favorite configurations. The other one is also we're starting to see integrated digital car assistants where you give voice commands and they react to that. In terms of vehicle safety, because all these sensors are acquiring a lot of data, they keep track of the car health and they warn you if there's a problem, and they can even tell you, okay, this is the closest gas station or the closest place to take your car. It also allows the car to be more aware of its surroundings. So it can detect there's a pothole, or it can be informed through the cloud or other cars that, oh, there's an accident happened over there, and then it can reroute you. And so all of this is because now we are acquiring this real-time data. And other thing is in terms of cybersecurity. So the more sensors you put in the car, there's more risks of, have more entry points for hacking. So this kind of big data and cognitive services allow to monitor the system at the same time and detect anomalies and prevent hacking. So basically, I think one of the biggest things is with perception. So 95% of traffic accidents are actually caused by human error. And so if we can help with any technology that prevents that, of course the automakers want to adopt that. So one of them is, for example, now you can do driver state monitoring. So you have sensors in the car, and they can do facial recognition, or they can do eye tracking, and they can identify if you're getting sleepy and send a warning so that you alert, or they can even bring the car to a stop. Another one, this is allowing rich visual experiences. So now you can use augmented reality to project information on the windshield for the driver, and the driver just can keep the eyes on the road. So you're not distracted looking at the screen in the car. And a big one that I guess most people are familiar with because of the self-driving cars is object detection. And there are already systems in the road where you have cameras in the car, and they can detect the lanes, and if you're shifting from your lane, they'll give you a warning. They can also detect pedestrians and traffic, and they can give you warnings to avoid accidents. And next I will go into the use cases that Vortex and Altran have been working on. So the first one I'm going to talk about is an app and an API that we developed for in-vehicle help. And actually we have these in our booth downstairs if you want to check it out. And so in the past, if you wanted to figure out something about the car, you got a warning, you would have to go to the manual, or maybe, and so what this app does is you can buy a car, it comes with basic car information, but that information can be updated over the air. And also you can use, for example, voice commands to ask something, and it will provide you that information. Or you can also use an augmented reality app and point at something in the car, and it will retrieve that information for you. Another project is related with street parking detection. So in a lot of European capitals, we can spend around 20 to 30 minutes looking for a parking space, and that adds to the congestion. We increase our fuel costs, and also we are increasing pollution. So Altran partnered with a client that they wanted to build this machine learning model to detect free street parking spaces in less than 3 minutes. So we would go from 30 minutes to finding a parking spot in 3 minutes using crowdsourced data and smart sensors and computer vision. So to build this solution, they used the in-car cameras that their users' cars already have, and they will use computer vision algorithms to, as the users would drive, the algorithm would identify there's a parking spot here, and they would register that into a database and the time it was recorded. And then data-driven algorithms were used to calculate the probability that, if you had another user going in that direction, the probability that that parking spot was still available, and then it would reroute you to the one that it had the highest likelihood that it would still be available for you. And we achieved an accuracy of 80% confidence per space. So that's... and so the next projects are some of our Vortex projects, and one of our focus research areas is in the extending vehicle horizon. And so basically we're interested in complementing the real-time computer vision with other information that you can receive or from the cloud or from infrastructure or from other vehicles. But a lot of the heavyweight is going to be done by the real-time computer vision, and it can alert you. I guess I need to go back to start again. But it can alert you. So, in this image, you can see, the different colors correspond to the different objects. So it can identify, okay, this is a pedestrian, and it's going to walk almost in front of you. So maybe stop the car. Oh, it started again, sorry. And so a lot of the successes in autonomous driving is related with computer vision, but we believe some of the challenges for the future are going to be related to data safety and to cybersecurity, and so we plan to tackle those in the future. So here I'm going to talk a little bit about how does it work. So basically in machine learning, you have two different major components. One is the training, where you teach the model what to learn from, how to interpret that data and what to learn. And this constitutes the bulk of the work. And this is a very data-intensive process. So for example, an autonomous driving car can generate terabytes of information in a single day, and then you have to process all that information. And so typically that is done in the cloud. And also some of these models, besides the amount of data, they can take months to train. So typically I do all of the model training in the cloud. But then the car, when you're in the car, you need real-time information. So you cannot afford to be that the information doesn't reach you from the cloud because of some issue with connectivity or something like that. So typically what happens is you train the models in the cloud, but then you run them in the car in real time. And so then what happens also is as the car acquires more data, it will keep sending that data to the cloud. You refine the models in the cloud, and then you will send the updated model back to the car. And so basically, to successfully apply these models in the real world, you actually need real world data. That is the ground. So basically, this is the ground truth data that you're going to use to train your model. So that has to be based in reality, and that is what's going to teach your model what to learn and what to do. And so this means actually is the least sexiest part of doing AI, but actually the data collection and the curation is one of the most important parts. So 99% of the time you're driving, it's really not interesting. It's just, it's always the same. And it's that 1% that we're trying to identify, and that's where we want to train our data on. So there's a huge effort to just identify which data, which cases you're seeing that are different from what you already have and that you want to train on those. And so basically, this kind of ground truth typically is done by human, and that takes a huge amount of effort and a huge amount of time. So there's a lot of effort to develop automated and semi-automated tools to annotate the data, so that then you can train the models. And so basically, we are building one that can do both object detection and semantic segmentation. And so the way it works is the user is going to upload images of video or going to upload video or images of raw data. Then our algorithms will give a suggestion of, we think this is a car, we think that is a bicycle. And basically the human just reviews, and if there's something wrong, he will correct it. And so this speeds the process by tenfold or more. Especially in the semantic segmentation, where you have to paint every pixel, it can take 1 hour per image. So if you use these methods, it can take maybe 5 minutes. And so we also have a feedback tool. So if the algorithm misclassified something, then the human has to go and fix it. Then we send that information and retrain the algorithm. And so the tool just keeps getting better. And so now I'm going to talk a little bit what are the current technical challenges. So I've talked about a lot of progress and a lot of great things, but there's some major things that have to be solved. And so we hear about breakthroughs in algorithms, like it seems like there's a new paper every day. But there is, I think, a big problem these days is that all of these algorithms, they work for what we call narrow AI. So you train the algorithm to perform a very specific task, but if you try to apply it to do something else, it just breaks. It doesn't work. So this is crucial to advance. Is like we need AI models that they can generalize across tasks and across domains. Another problem, which is related with the first, is that you need lots and lots of labeled data for each of the tasks that you want to train algorithms on. And another thing which I kind of hinted at, so this kind of technology doesn't handle edge cases well. And what are the edge cases? Is the situations that are rare. They don't happen very often, so you don't have enough data to train your algorithm on. But if you're driving, those are going to happen. So this is a big problem right now. The other one is a lot of these algorithms, they are deep learning algorithms, so they're a little bit of a black box, and you can't really understand why you're getting a result or why, it's recommending a certain thing. And maybe, if it's a Netflix recommendation, that's okay, but if it's for it's recommending a medical procedure, the doctor wants to understand why it's recommending that particular thing. Also, if it carries societal implications, like doing, recommendations for criminal sentencing, that's another problem if you can't explain why you reached a decision. Another thing is, better automated life cycle management techniques need to be developed. So we need to be able to detect when the test data is driven and when the algorithm needs to be retrained on what data. And so there's a little bit of that, but more research is needed in this area. And so basically, if we're able to solve all of these challenges, we're going to be able to arrive to cognitive systems that they're going to be able to reason. So that is a thing that the systems these days, they cannot really reason. And they're going to have common sense, like we humans do. And so that would be the biggest advancement, is okay, it would still work in all these areas, but it would understand what it's doing, and like we humans do. And so I guess I'm reaching the end of my talk. And so basically, I guess my main message is cognitive computing is here, and it's just going to keep on growing. And it's already affecting us in our everyday lives and how we're moving around, working, learning and making decisions. And the auto industry is aware of this, and there's some pioneers and they're already leveraging these capabilities to improve their business. And as we make more progress, I can't even imagine what else we're going to be able to do with this technology. And thank you for listening.
Thanks, Joana. We have about 2 minutes to challenge Joana with 1 or 2 questions if you want to. So, anyone, any questions? No?
Okay.
Yeah? A challenge?
Thanks. So, in this cognitive world, we see lots of data being acquired and processing, and sometimes it looks like that the car and this kind of devices always need to be connected to the cloud to have access to additional computing. How do you see the computing on the edge and what's going on at the moment on that side?
Ok, não sei. Agora posso falar em português. Quero saber, eu não percebi tudo. Quero saber
o que é que está a acontecer neste momento em termos de edge computing para combatar quando o carro ou o dispositivo não tem acesso aos dados e à cloud? O que é que está a acontecer nesse domínio neste momento?
Em Automotive?
Por exemplo, poderá ser noutros.
Sim, eu acho que a tendência tem havido muitos avanços a nível de desenvolver tecnologias de inteligência artificial que correm no edge. Para já os processadores estão a ficar cada vez melhores e estão a ser desenvolvidos modelos ou seja, treinas o modelo na cloud, mas depois podes compactar esse modelo para correres no edge. Então, por exemplo, eu tinha um iPhone 10 e eu usava facial recognition para fazer um unlock, e aí eu estava a correr o modelo no próprio iPhone. Então essa tecnologia já está a ser usada em produtos atualmente. E é daquela forma que eu expliquei daquele gráfico. Treinam na cloud, mas depois o deployment é no edge device. E até neste momento, a nível de hardware, já começa a ser possível fazer um bocadinho de treino no próprio edge. Por exemplo, no iPhone, eu tive que mostrar a minha cara, ou quando se faz impressão digital, não é? Temos que fazer várias vezes e estamos a fazer esse treinamento localmente. Não vai para a cloud da Apple, é feito ali mesmo.
Joana, uma pergunta. Vivemos num mundo cognitivo, cada vez mais se fala da AI, conseguimos fazer algoritmos preditivos, vamos agora fazer prescritivos também. Na parte de Automotive, o carro vai ter que começar a tomar decisões. Decisões se vai atropelar o peão, porque detecta que é um peão, ou e matar provavelmente o peão, ou desviar-se. E se calhar fazer danos aos ocupantes. Como é que tu vês a nossa capacidade neste momento e os developers que estão a tomar essas decisões de o fazerem?
Então, eu acho que há bastante... eu acho que para termos um autonomous vehicle, nós vamos ter que ter diferentes tipos de tecnologia e vamos ter que desenhar o vehicle para ser sempre seguro. Então, vai haver uma combinação de decisões feitas por estes algoritmos de deep learning, mas ao mesmo tempo também vai haver rules-based. Portanto, se um falhar, vais ter o outro algoritmo por trás que vai dizer não, isso é a decisão errada e não podes fazer isso. Eu acho que as duas vão conviver. E acho que tens de ter grandes equipas a trabalhar nestas coisas que venham até de campos um pouco diferentes, com visões diferentes, porque tens que integrar várias tecnologias para realmente construir um carro autónomo. Não pode ser só pessoas de deep learning ou só pessoas de rules-based pronto, acho que é assim que eu vejo.
Obrigado, Joana.
Obrigada.
Obrigado a todos.